if I do it right, and it didn't work. Let's see if we can get it just straight from here. We have to do it. No, come on. Whoa. Did not make enough. This is a harder one to do. If you have dry ice,
can I get
it's
closer?
very easy to...
Does it pop or something? No, I mean, no. Before the gas is like...
It's going to blow up in front of my
Okay,
face.
so we're making more carbon dioxide, hopefully trapping it in this container once it stops bubbling. Okay, so we're going to pour the gas out. And it extinguished, right? So I didn't put any water on it, but I was able to pour the carbon dioxide, okay? So using kinetic molecular theory, why are the gas particles able to flow like a liquid?
Because they're heavier than air.
Well, they're heavier than air, okay, yes, but the gas particles themselves, why are they able to free to move? If I were to grab an ice cube, if I grab an ice cube and I try to pour it, yeah, but what does that have to do with, so I'm trying to pour this ice, the ice isn't pouring. All the molecules are attached, there's attractions between the molecules, right? Very strong attractions when we're dealing with solids. But the gas, you know, there's a lot of empty space, there's no attractions between the particles, so they're able to flow kind of like a liquid. We have liquid water, right? So this is able to flow. I can pour it from one beaker to another.
I think you should pour
pretty
it
easily, right?
Prove that.
So it's flowing because they have liquids are slightly different than gases, but they're still able to move. The particles are able to kind of move back and forth versus a solid where they're stuck together, right? Can't flow using particles, okay? And the next one, so this one is, I tried to get this set up. I think it probably needs to go for a little bit longer. But, so we have a balloon. This balloon is, essentially what I did is I just did the vinegar and baking soda thing and I trapped some carbon dioxide, okay? Now I have this kind of heating up somewhat, and that's just really hot. So as it's heating up, what should happen to the particles inside that balloon?
They move faster.
They move faster, perfect. And what happens if they move faster? What happens next?
The balloon will blow up. They'll hit the sides faster.
Why? They hit the sides faster, right? Okay, so this way we're kind of cheating because there is liquid in there, so we're actually heating up the liquid. We have a little bit of evaporation, so there is some extra particles getting put up there. But gradually this balloon should kind of blow up. You can kind of see it. Is it getting bigger? Can you notice?
Oh, yeah.
I saw it a little bit, right? So it's heating up. The particles are heating up. What does that mean about its kinetic energy? The kinetic energy of each particle is speeding up. It's going faster. So when I throw a slow pitch softball at Cole's head, Cole, where did you? Cole, yes, Cole's head. It's going to be more or less pressure than if I had a fast pitch baseball and I hit him square in the head.
Less.
Less, right? Because it's moving slower. So the slower it's moving, the less pressure it exerts. If it's moving fast, it exerts more pressure, which means it's able to expand the balloon. Okay? So yeah, we can really see it kind of getting nice and big now, right? Everybody sees that? No, because now we're going to do the opposite. So if I add ice to it, what happens? This is really hot. Oh, Lord. It's going to get smaller. Absolutely.
Woohoo!
Okay. Yeah, I mean, that's fine. And the steam inside here is real hot, too. So this could take a very long while, actually. But we can kind of see it. It's cooling down, and the gas inside the balloon is losing kinetic energy. I mean, it depends, you know. Since you are heating up the rubber, it'll probably stretch a lot more. You might melt the rubber, so you'll get a hole somewhere, maybe it'll pop. But now the balloon is a lot smaller, right? So we've cooled it down, we've taken away kinetic energy, which means the particles are moving slower, which means that it's exerting less pressure on the balloon. So it can't expand it as much. So now we're about to the size that it was initially, right? About. And if we keep cooling it past, we should be able to get it to go a little bit less than its original size, but we're not going to wait here all day. But so we understand the idea of heating or cooling a gas. How does that change the way the gas is behaving? The key point. What's the key point? Kinetic energy is changing, right? which means that they are able to exert less pressure. Okay?
I thought the main point was that you sound sexier with SF6 in your class.
Well,
Wow,
that may be
Corby,
true.
really?
Okay.
Isn't that your teacher, man?
So,
Especially if the teacher's a guy.
Okay, I'm just saying you as in like everyone.
the
Okay.
final demonstration.